So our client needs must be, the blood pump itself must be mass produced in order to reduce its cost. And the variable speed must be ranging from 0 to 100 meters per minute with volumetric accuracy of 5%, plus minus 5%. The pressure head within the pump itself must be negative 100 millimeters of mercury to 100 millimeters of mercury. So it is also desired to minimize blood damage, mainly hemolysis, and be limiting the pressure, vacuum, and shear rate. It is also desired to naturally have a fail-safe design without relying on alarms in order not to exceed the safe limit. The diameter of the tubing is reduced to the entry point of the body hole and the side of delivery tubes provided for the blood flow to the organs downstream from the catheter insertion point. So for the specification of our pump, the pump itself, the size of it must be 30 by 30 by 25 cubic centimeters, and the overall fixture must not exceed 30 by 30 by 30 cubic centimeter. So the lower area of the pump, of the pressure side, must be greater than the suction side, since the blood is more tolerant to pressure than vacuum. So inside of the tube and the catheter can be treated to minimize clotting by adding an anticoagulation coating such as hairpin or texturing the surface. Have a collapsible outer delivery tube and an inner suction tube that can be collapsible as well.
Disposable blood pump, we have three constraints to be considered. First constraint is disposable of the whole pump may cost much. The second is the blood accumulating on the pump's fins, since this can affect the flow rate over time. And lastly, the thermal management of the pump. High operating temperature can affect the quality of the blood being treated. And for our design matrix, we have these following criteria: the cost, maintenance, efficiency, reliability, and strength of connection. We are giving the cost the weight of 30% since it's the most important factors that can affect this product. The next is the maintenance that has 20%, efficiency 20%, reliability 15%, and strength of connection for our software to be installed in the product of 15% for a total of 100%. For our sketch, this is the isometric views of our blood pump.
This is our blender design. So as you can see in the figure, the upper part is for the blood to exit the pump, and the lower part is the intake part. So the specifications for this pump is presented in the previous slides.
For the program part, we use the language that is C# for the console application. And then to start in our program, first you will need to enter the minimum blood current speed of the device, and that would be range from 10 to 19 milliliter per second. Then after that, if the inputted value is not in the range, the program will not simulate. And then after the minimum value, the next would be the maximum blood current speed, and that would be range from the minimum up to 20 milliliter per second. Then after all the inputted values are correct or in the range, the program will now simulate. it will be displayed in the program the disposed blood and then the total treated blood, and also the speed of the blood current. And then the whole program will end if the total disposed blood had collected for about 100 milliliters. And then you will see in our program the console application. This is program using the C# application, C# language. And then after the program had finished, you will just close the console and just run it to start the new set of simulation. Aside from the console application that we had programmed, we also programmed a Windows Form application. The console application is for the device itself, so that it is programmed on how the device would pump the blood. And for the Windows Form, it is programmed for the user so that the user can easily understand and see all the values that have been generated in the simulation. Here in the Windows Form that we had programmed, there is also a minimum blood current speed and also a maximum blood current speed. If you had inputted the minimum and maximum blood current speed, you should press the start pump so that the simulation would start. And also, just like in the console application, the program will stop or end if the value of the disposed blood level had reached 100 ml.
The level 1 data flow diagram is about first the control panels, which interact with the users. Then it configures the system, and after that it sends the automatic deactivation or activation of the system. Then the sensor, which it monitors and display the message. The concept screening, you can see that the number 1 is the parallelistic pump, the number 2 is the ventricular assist device, the number 3 is the pump roller, and the number 4 and 5 is the one that we didn't that we removed from the choices because it has a negative score, the Nova Core pump and the parallelistic pump.